This is lesson 18, day 3. We got 3 problems, 2 different types. The first one, guys, is a mixture problem. And so I have a very easy way to figure out mixtures. The way mixtures work is about average rates. The thing about it is, let's say that you are going to get together with a group of people and you're going to buy something. Now, let's just say that all of you guys say maybe work at the same store, but you guys all have different years of experience at the store. And so, therefore, the store says the more years that you are a person that works there, the bigger your discount is off of whatever you guys are selling. Make kind of sense a little bit, right? So, say you got 2 or 3 people put together, and you guys all get to stack your discounts in a certain way together to buy a certain object. Who do you think discount counts for more if you guys all use your discounts at the same time? The one that worked there the most, right? Because he's got a bigger discount. Okay? So his would be used more, his or hers, would be used more, so therefore, if I was going to figure out the discounts, it would be used, you could see that it's drawing closer to that, say, discount. Maybe that one doesn't get in here. I'm just trying to think of the easiest way to figure something out, or at least to self-check yourself with percentages, is to figure out which one you're closest to at the end. How should I say this? Is if I was going to mix 2 things together, can you add their percentages together? So can I take a 5% and an 8% and I'll end up magically with a 13% solution?
No.
No. It doesn't work that way. You can't add percentages. But if I take that 5% and an 8% solution and I put them together, I go somewhere in the middle. You got to meet in the middle someplace. A 5 and an 8% could make a 6% or 7% or somewhere in between there. But you can't make something larger or you can't make something smaller. That's like saying, hey guys, I really don't like strong coffee. So to dilute my strong coffee, I'm going to add a stronger coffee. Does that make sense? No. No.
Well, what you're saying makes sense, but the thing doesn't make sense.
Right, adding a stronger coffee to your coffee does not make it a weaker coffee. And so that's what we're trying to get at here. So, what they're going to have here is they're going to give you information about either how many gallons of some kind of percentage or how many gallons at the end you need. And you need to find both quantities going in or how much is on the way out. And so, let's try a problem here. Is to get 1,000 gallons, so now you're trying to make something, that a mixture that is 56% alcohol, it was necessary to mix a quantity of 20% alcohol with a quantity of 80%. Wait, 20%? Adding 80?
100%.
No, not this is what we're talking about. I can't take a 20% and add 80% to get 100%.
So you get like a 40.
Okay, think of it. If 20% of them are green, and I'm adding another mixture that is 80% green, are now 100% green?
Oh, no, because you still have the other color.
You still have the other
red
stuff.
or whatever.
Right.
Gotcha.
Maybe that's a better analogy,
That's a
right?
really good way to look at it.
Okay. So, how much of each is required to make that happen? And so, basically, I have a lower quantity, a lower percentage alcohol, 20. I'm going to add a stronger alcohol to it of 80%. So when you mix those 2 together, it should land in the middle, right? 56% is somewhere in the middle. And so this is how I'm going to do this, guys. I am going to create a table. This table is going to have a couple rows and columns. And it'll look like this. What I want you to do is on the first column, I want you to put the percentages going in to the mixture. And then in the very bottom row of that column, I want you to put what was made. So what is going in to make stuff? What percentages? 20% and 80% to make a 56%. Now, because a percentage itself is really nice, because I can use it as a label, 20%, but I know deep down inside that 20%, if I ever really wanted to use it, I have to convert it to a what? Decimal. Really easy to do. It becomes what? 0.2,
Yeah.
and then 0.8, and 0.56. So generally, I will let this go as both a label and a number at the same time. Now, what we're going to put across the top row in that first column is we are going to put gallons of the mix. So what we're going to have is a bunch of mixture. This mixture, each one has their own. There's a 20% mixture. That's 20% alcohol and 80% who knows what. It could be water. It could be anything else. The other one's 80% alcohol. And the other one, the last one we want to make, is 56% alcohol. The last column is going to be gallons of alcohol. And what we're doing here is we need to figure out exactly how much alcohol is in each of the mixtures given a certain quantity. Let's go back to the green candy. If there's 100 pieces of candy and if 20% of them are green, how many are green? 20. 0.2 times 100. If there were 80% green, you would say 80. 80 out of the 100. There would be 20 only green ones. There would be 80 only green ones. Together, if I mix them together, I would have 100 green ones. And we're going to talk about that in a second. But when I say gallons of mixture, that means the whole thing. And gallons of alcohol means I got something I can compare. Because the alcohol of the 20% added to the alcohol of the 80% should equal the alcohol of the final result. Right? Putting them all together. So now you start to say, okay, I got my labels. Do I know any of these pieces of information? What other number am I not using yet?
1,000.
1,000 gallons of what?
Mixture.
Of what percent?
56.
So 1,000 goes on the bottom. Here's a cool thing. There's a 56% alcohol mixture of 1,000 gallons. Can you actually tell me how many gallons of alcohol you have? How much?
560.
How did you figure 560?
Because 56% of 1,000. Well, it's because 1,000 is 10. Like,
It's multiple of 10.
Yeah,
Okay.
Yeah.
You're multiplying. If you multiply 56% times 1,000, because each gallon is made up of 0.56 gallons of alcohol. So if you have 1,000 of them, you have 560 gallons of alcohol. Here's the cool thing, guys. This will work every time in this box, in this table. Multiply across. Write that down someplace underneath there or something. You multiply across. Now, here's a question. It wants to know how much of the 20% mixture is added to the 80%. Do you know them?
No. So
No.
X and Y.
Yeah, so a lot of times we like to say X and Y. I'll call that X, but I really do not want to call the other one Y. Why could that be? Why would it just not be a good idea to call the other one Y? What did we talk about the other day about equations and variables? The more variables I introduce, the more
More.
equations you need. I don't want to create more equations. So is there some link, guys, between the X gallons of 20%, some unknown 80%, and 1,000 gallons of 56%? Is there a link between them?
They're the same thing.
What do you mean? They're the same thing.
They're within each other.
Explain that even more.
Well, because it's like 100%. No.
No, I can see where I can make this fit or work, but I want you to explain it. Jan? What's that?
80% of X times 4.
No. Hey guys, think of it this way. How much do we want to make?
1,000.
1,000. What if I told you you added 100 gallons of the 20%? How much 80% has to go in?
100, wait.
If you got 100, I don't put X, I put 100.
Okay.
If I put 100 gallons of the 20% in,
Yeah.
you can only have 1,000 gallons at the end. How much is 80%? It's 900, right? So if I put 500 gallons of 20%,
500.
how many gallons of 80% can I have?
500.
250?
500.
500 now.
500.
Guys, this column,
Oh.
X plus whatever this is, has to equal 1,000. Your container only holds 1,000 gallons, and you need 1,000 gallons.
Oh.
So this could be 800 and 200. It could be 500, 500. It could be 300, 700.
Oh.
But I'm not going to sit there and guess and guess and guess.
There's a way to do that.
If I call the top one X, what's the next one then? I don't want to call it Y. We're trying to avoid using Y. Guys,
It's just a number. Like,
if X is 1, how do we find out what the other one is? No, it's not A squared plus B squared. Guys, everyone stop. Think about this. I'm telling you X right now is 1. How much 80% is there? Just 1 gallon. I'm putting 20%. 999. How did you get that? How did you get that?
1,000 minus 1 is 900.
1,000 minus 1. If I let it be 200, you would say,
800.
why?
1,000 minus 200.
Okay, now it's 1,000 minus 200. So if I call it X, what am I going to call the other one?
1,000 minus X.
1,000 minus X. Now, here we go. I'm going to write the rules down. You can multiply across, like I already said, right? X, 1,000 minus X, and 1,000. How are they all related then? You add down. X plus 1,000 minus X, the X's cancel, you're left with 1,000. The top two will always add up to equal the bottom.
Oh.
Hey, wait a minute. If the last row worked to the fact that if I can multiply across, can't the top two rows do the same thing?
Yeah.
What is 20% of X?
29.
No, it's not 20X. It's 0.2X. What's 80% of 1,000 minus X? 0.8 times 1,000 minus X. And according to the last rule at the very end, the top two will add up to the bottom row. 0.2x plus 0.8 times 1,000 minus x
Oh no.
equals 560. One equation, how many variables? One different variable. Therefore, you can solve it. I'm going to give you guys a couple seconds, a minute or two, solve that. So, 0.2x, not changing, plus 0.8 times 1,000, 800, minus 0.8x, oops, equals 560. If I gather up like terms, 0.2x minus a negative point, or minus 0.8 is not changing anything else. Subtract 800
So then you get 240 or negative 240.
equals negative 240.
Divide by negative 0.6.
Divide by negative 0.6.
Divide by negative 0.6. X equals, what is it? 400.
400. 400 gallons of what?
Mix.
20%. That's X. It wants both. This one's not too bad because they have to add up to what? 1,000. So it's 1,000 minus 400 is? So 600 gallons of 80%. Now, let's talk about this results. It seems to be I got more 80% than 40%. This one kind of went back to that idea of that percentage off from people. If I use more of the 80%, that means the mixture will be closer to 80%. You're using more of something. Now, let's take a look. Take a look back at 20, 80, and 56. Is 56 closer to 20, or is 56 closer to 80? 80. It's closer to 80. So, in my mind, I need to use more 80. The results are, I used more of 80. Therefore, it's kind of helping me check to make sure I'm doing things right. What happens if you think it's directly smack dab in the middle? See, the middle between 20 and 60 or 80 is what?
Add both divide.
Is it 50? So if it was at 50%, how much of each would you have to use then? 50. No. It'd be 50-50 or 500-500, right? So there's ways sometimes to rationalize your way through this problem. My brother-in-law does this for a living.
What do you do?
Math teacher?
No. He deals with percentages on CNC machines.
What's a CNC machine?
Those machines that cut metal, those die cutting machines that make parts
So
for
basically like
suppliers.
programs thing?
He doesn't program. He's the one the guy comes back and cleans the machines, changes the fluids, filters, and all that. But what he has to do, the machine is calibrated for a certain percentage range. So the machine needs to have a 60% solution of whatever it is for coolant and all of that lubrication. And he goes to the machine, he can take out, he tests the fluids, and it says, hey, we're only running at a 30. You need to be at least at a 40 or 50. He needs to figure out, okay, the machine already holds this much fluid. Now, if I take out 20 gallons, and if I want to put another 20 gallons back in, what percentage of the 20 gallons or what I have on hand do I I need to add to make this go into the right range so that you can keep using the machine safely. He does this without any writing history. And I've actually tested him. The way he says it and the way I do it, we both are correct. It's crazy. He does it for a living. He doesn't need to look at stuff. He doesn't need to write it down anymore. You guys all want to look in your books. You want to look in your notebooks. Look at this and that. But eventually, guys, because you always have it. Guys, when you use something all the time, you don't need to reference it all the time. Okay? That's kind of a goal in life, is to make things going to be more efficient. Okay. How many... Guys, I am recording. How many liters of a 64% glycol solution must be added to 77 liters of a 23% glycol solution to get a 42%? Notice 42 is in between 64 and 23. Glycol is the alcohol in antifreeze. This is why your car is not freezing right now. Well, it's freezing because you get into it, it's cold, but your car engine doesn't crack. All right, set it up and try to figure it out. Okay, guys, you should have something like this table quickly drawn in. The question that came up was, does 23 and 64, does it have to be in that particular order? No. You could have put 23 first and then 64. But what I will tell you is that 42 has to be in the last row. Has to be. For the plan, guys, to multiply across and add down, for that to work, you need to have it set up this way. Does anybody have something else filled in with any of this?
Yeah.
77 goes where? Bottom corner. No.
No.
It goes by 20.
It goes by the 23 of the solution or mixture, right? Maybe I should have put liters of solution. But this should be 77 associated with the mixture of liters of mixture for 23. And then we could take 0.23 times 77. 0.23 times 77. That'll tell us the amount of pure glycol in that 23% with 77 liters of it. How many liters would you have? You would have a whole bunch. 17.71 liters of pure glycol. Okay? Now, here's the question. It says, how much, right, of 64%? And if you knew that, you could multiply across to get 0.64x. So as soon as you know x, you would know exactly how many liters of glycol you would have in that mixture. Multiply across. But wait a minute. It said to do what when going down?
Add.
Add. So what's that last row? 77 plus x, or x plus 77. I just like to keep my variables first, but yes, 77 plus x, or x plus 77. The other one, oh wait, I'm not going to do that other one yet. I'm going to multiply across first. So this becomes 0.42 times x plus 77. So the really cool thing about it is 0.64x. Now I'm going to add when going down here. Plus the 17 point, what? 71 equals 0.42x plus 77. Distribute the 0.42, gather up the x's, and solve it out. I'll give you guys a couple seconds to keep going on that one. 0.64x plus 17.71 equals 0.42x plus, what's 42% of 77? 32.34. I think it'd be best to subtract 0.42x from both sides.
Yep, and you get 0.22x.
I'm going to subtract the 17.71. 0.63. Then divide both sides by 0.22. So x is equal to, it's about 5 times that size.
66.5.
66.5 liters of
Solution. Glycol.
64% glycol. Because it's a percent. It's a 64% glycol. Do we even care how much is at the end?
No.
But could we figure that out too?
Yeah.
I just add the 66.5 plus the 77, right?
Oh, yeah.
Danielle,
Homework, day 3, page 137, 6 and 15. Have a great day.
What is it?